All right, welcome to mission 3. This is where the rubber hits the road. This is the tough one. Okay. What you'll see from this video is now instead of just using basic physical traits and fossil evidence, things that Darwin had available to him when he developed the theory of evolution, you're going to dig into the genetic side of evolution, the DNA. This allows you to find really, really precise information about species. And so this is how we do all modern taxonomy. This is how we sort things as modern scientists. Every publish has a DNA sequence. Every time you publish something about a new species, you take its DNA sequence, you submit it, and the computer can literally figure out what the closest related relative to it. Let's like say you find a new spider, we can find the exact closest related spider to that in the world just by sequencing its DNA. It's fantastic. It's the way modern science has brought us to, and it makes these actually, I think, a lot simpler. So if you'll notice that down here, you have the graph. So it says the chart. So there's position 1, position 2, position 3, position 4. These are the A, T, Gs, and Cs, which you already know about. But notice what it took away. There's no longer that information about physical traits or current whatever. Okay, because at this point, it doesn't matter. These are all living creatures, and we can sequence their DNA, and we can simply use their DNA to know how closely related they are. And so what it did for you is it made this little cheat sheet. Notice that graph is the same as, sorry, that chart is the same as this chart, has the same outgroup highlighted in a different color. So always pull your outgroup over to a side. I always prefer to put the outgroups to the right. It's just the way my mind works. And then since these are not a part of the outgroup, you'll always be adding to the tree in this direction, or you can move the outgroup to the other side. Hey. Oh, maybe you can't. Okay, I thought you could. So now you're looking at C at position 2. You go over here, 1, 2, there's C. All of them have it, so it's from their common ancestor down at the bottom of the tree. Now T at 3, which means T comes in right there, hopefully. Yay! Okay, DNA sequence of the West Indian Ocean. Coelacanth is closest related to which species? It is actually related closer to a frog than it is to a similar fish. So that's a fish that's close related to a frog than it is to a fish. That's important. We actually thought coelacanths were extinct for a long, long time because we only found fossil evidence of them, and then we started fishing really, really deep just off the coast of Africa and caught quite a few coelacanths now. Pretty cool. Okay, again, keep working through this. Just like previously with those attributes, now the DNA is going to get more and more complex. So as you're working through that, just go back to the basics. Whose DNA is most like whose DNA, and it becomes just matching at this point and putting everything together. Again, if you get stuck, let me know. I can work through this with you on a Google Meet. Just send me a reminder and we'll set up a time to make sure you get through all of this. All right, keep working hard and go get them.